Okay, this is number 25 on page 75, and this is kind of a doozy to get it all set up and simplified, but just if you have patience and tenacity, it's not too bad. So I want to isolate, remember, the absolute value expression on one side of the inequality for starters. So the first thing I'll do, if that was just a variable, if this was just 4 plus 2x is greater than 5, you'd first subtract the 4, and then you'd divide out the 2. So that's what we're going to do in this case also. So if I subtract 4 from both sides, minus 4, I'll have a 1. Now I'm going to divide both sides by this 2 out here. So I'll draw a 2, and I'll divide by 2. And this will cancel. So I've now isolated the absolute value of 3t minus 5 over 2. That expression is greater than 1/2. And what we're looking for here is a value of t that makes the value of this fraction more than 1/2. Okay, either, to the left of negative 1/2 or to the right of positive 1/2. So I'm going to take the expression out and find my critical points. So I'm going to set it equal to 1/2, and I'm going to take that expression and set it equal to negative 1/2. Remember, I'm not solving it here, I'm just finding critical points so that I can graph it and evaluate to solve. So clear the fraction. So 2 for every term, I will have a 3t minus 5 equals 1. So 3t is equal to 6, so t is equal to 2. On this one, same thing. Clear your fractions. So I will have a 3t minus 5 equals 2 divided by 2 is 1 times negative 1 is negative 1. And then I'm going to add 5 to both sides. Plus 5 plus 5, I'll have a 4. So t is equal to 4/3. So those are my two critical points. So now I'll plot those on my number line. And I'm going to zoom in on the area because this is 1 1/3 and this is positive 2. So my zero's out here. Let's kind of spread this out. So 2, and by the way, these are going to be hollow points if I go all the way back up to my original. So here's 1 and 2. So I probably should have spread this out more, but anyway, 2 is a critical point, and then 4/3 is right in here. A little to the right of that, because it's 1 1/3. Okay, so I now divide the number line into 3 intervals, to the left of 4/3, between 4/3 and 2, and to the right of 2, not including either of those points. So I'm going to test 0, because that's an easy one, and put it into my original inequality. So let's do that. 4 plus 2 times 3, and I'll put in a 0 for t. So I'm putting a 0 in for this t. Minus 5 over 2. How does that compare to 5? So this is 0 down here. 0 minus 5, so negative 5/2. So 4 plus 2. What's the absolute value of negative 5/2? It's positive 5/2, just 5/2. So 2 times 5/2 is a 5. So I have 4 plus 5 is greater than 5. And that is a true statement. 9 is greater than 5. So 0 makes the original inequality true. So that means that everything to the left of 4/3, in that range where 0 is, will make the inequality true. Nothing in here will work, or should work, and everything on this side should work. So I'll leave it to you to substitute a value in this range to test. You can use a very, very large number if you like, to show that it makes it true. And if you'd like to pick something like maybe 1.5, anything else, 5/3 if you want, would be a good one to use up here to test. Nothing in here should work. So to evaluate my actual answer, It's that t is less than or to the left of 4/3, or t is in the interval that is to the right of or greater than 2. And that is it.